Our first speaker knows a thing or two about operating systems at scale. Cheryl Hung is a tech executive with 15 years of experience across companies like Google, Apple, and ARM, and also the Cloud Native Computing Foundation. And today she brings her deep expertise in cloud native systems to one of the, in my personal opinion, toughest architectural challenges we face in AI-driven ecosystems: customer identity and access management. Cheryl will explore whether vibe coding can actually rise to that challenge. So give her a warm welcome, Cheryl Hung.
Thank you. Hello, good morning, everybody. My name is Cheryl Hung. I started out as an engineer at companies like Google and Apple. I moved into developer advocacy as a way to educate and tell other people about technical trends, especially around cloud native and containers and Kubernetes. That's how most people know about my work, through the Cloud Native Computing Foundation. And then I moved on to become an ecosystem leader. And ecosystem in this case could be building an open source community around open standards like Kubernetes, or it could be a commercial thing like I was doing at ARM's and software support for ARM64. But my interest has always been in how you organize people around a shared common goal, a technical vision. I'm also the founder of Cloud Native London. This is a meetup group that I started in 2017. We have over 10,000 members now, and still run monthly events. If you are ever in London on the first Wednesday of the month, please come along. It would be very nice to see you there. So this talk came about from a conversation that I had with a friend who works at a startup that implements cloud authentication. And the challenge that he and I talked about was, could you vibe code something that would effectively kill off this startup, right? Could you vibe code an application that would implement on-premise standards-based authentication? So why authentication? What makes this an interesting problem? The first thing is it touches everything and everything. Your banking, your healthcare, your family life, your hobbies, everything. I have over 300 passwords in my password manager. And if the future of AI agents really works out, I may have tens of thousands, because maybe every agent that I'm spinning up has to have its own identity, and it has to be authorized correctly so that it can be auditable, and all the actions that this agent takes on my behalf can ultimately be traced back to me. So that means authentication is not only a difficult problem now, but it might get even more complicated in the future. The second challenge is this typical trade-off of security versus usability. I just said we have to get authentication right. There is no way that we can, accept that this is incorrect. But also, we humans are very lazy and we like to take the path of convenience. So there have been some measures to try and improve this trade-off, things like passwordless or biometric authentication. And the question of scalability comes in because now we're not just doing this over a single monolith. We're doing this across possibly across microservices and across cloud and across on-prem. So again, the question was, if I gave this challenge to AI, what side would it fall down on in terms of providing more security, more convenience for the user, or an architecture that would scale better? The third challenge is it's constantly evolving. So as I just said, security standards don't stand still. They're always moving. They're always updating. And they're updating in response to attacks that get more and more sophisticated. So it's an evolving arms race of attackers versus standards. And again, where would vibe coding fall down on this? And then lastly, the federated identity is even more difficult. So we expect in the future, perhaps, that agents will work across multiple different domains. So now identity that you build in your system must be correlatable to identity in another system that must be correlatable to every other identity out there that an agent might touch. So now we don't need to just think about our own systems. We need our identity to cross many, many systems. So all of this made this an interesting challenge for a vibe coding app. And this was the functionality that we started out with. What I think pretty obvious: username, password. You must be able to register. You must be able to log in. You must have a page that accepts that you can be let in or kept out of, and you need to be able to log out. And the requirements that we said was, does not use a SaaS provider and uses a local user database. So I gave all of this to Claude or Cursor, I forget, and spun it up. It gave me a nice little page. I played around with this, and it works. Right? I can register, I can create an account, I can put in a password, I can put in an incorrect password, and it keeps me out. I can log out, and I was like, oh, pretty good, first glance. But then, this was how it works in the background. So it was an Express server. It hashed passwords, which is quite nice because I hadn't asked it to hash passwords. It did session management for me with tokens, which was really nice because I didn't ask it for session management either. But then you look a little bit closer, and we're going to play a little game now of spot the bugs. Right? It starts fairly simple. What's the problem with this? Problem with this is that you're leaking information that accounts exist, right? So an attacker who puts in an account that already exists will know about that. What's the problem with this one? Opposite problem. Problem is, this leaks information about accounts not existing, just as bad. What's the problem with this? Problem is that we are not normalizing the account names in any way. So you check for duplicate accounts, but it's not case sensitive, which means that accounts can have multiple case sensitive variants. Marginally more complicated. What's the problem with this? There's no password requirements at all. Right? This password could be 1 character. It could be 10,000 characters. It could contain escape characters. It could contain emojis and Unicode and all sorts of weird stuff in it. But there's another problem with this. And this one is that it uses bcrypt. And according to OWASP, you should not be using bcrypt for new systems. How many people would have known that off the top of their head? Probably not many, right? And perhaps you could have interrogated the LLM and said, please make sure this is up to date. Please make sure you use the latest guidelines. But there will also be many cases when this kind of detail slips past because we're not all security experts and we don't always know the latest guidelines. So we're going to take a little diversion for a moment into security. And this is in the context of cloud and cloud native, but it's not really related to the cloud. Okay, so a little while ago, I looked at the CNCF surveys. These are surveys of developers that the Cloud Native Computing Foundation has run over the last 5-6 years. They ask, what are your challenges when using containers? And what percentage said security in response to this? So we're going to play a game here. When I was very little, I watched a TV show called The Price is Right, a game show. And in this show, the host would bring out a television or a household appliance, and the contestant would have to say, you know, the price is higher or the price is lower. And because I wanted us to focus on the trend here, we're going to play this as the price is right. Do we think that security has gotten easier or more difficult over the last 5 years. So in 2019, 40% of people said security is a challenge when using containers. Do we think in 2020 that that was higher or lower? Okay, so just put your hand up and say higher or lower. I think most people say higher. And it went down. It went to about 32%. What about for 2021? Do we think higher or do we think lower? More uncertainty now, more 50-50, maybe slightly higher in total. It went higher. It went to 41%. 2022, do we think it went higher or do we think it went lower? Oh, most people are saying lower now. It's definitely tipped over to lower. And slightly lower, maybe 40%. 2023, higher or lower? Higher. Yep, I think most people say higher, slightly higher. And very last one, 2024. Do we think it went higher or do we think it went lower? Oh, majority say higher. And it went lower again. Okay. So, look at this trend line. This trend line tells us that after 5 years of much work in the security industry and in architecture and in engineering, it seems we have got nowhere. Security is still almost as difficult a problem as it was 5 years ago compared to now. And why is that? Why does security feel like this Sisyphean task where you are pushing a boulder up and up and up the hill and then it rolls back down on you and you have to keep going? Why is security so tricky? So the first challenge is now we have cloud and we no longer own our entire systems from beginning to end and all the networking that comes in and out. There is shared responsibility between what the cloud owns and protects the infrastructure versus what you are responsible for, your applications, your teams, your organizations. And that means that there are going to be gaps when those things don't line up exactly and those things slip through the gap. It's very hard to detect these differences at scale. The second challenge is misconfiguration. The platforms that we have nowadays, cloud, Kubernetes, have immense power and flexibility, and therefore lots and lots and lots of different configuration options. But that means that security is more about misconfigurations. In fact, most security breaches are just about simple misconfigurations, not about very sophisticated attacks. For example, an S3 bucket that was left unencrypted, or some IAM role that is overly permissive. It's just very, very hard to detect and understand all of these implications and keep track of them and report on them and fix them. Identity is the new perimeter. As we said before, identity needs to be absolutely correct, and yet it's not always possible to map what we think of as identity within our organization to what the cloud provides us through the resources and the IAM permissions. So if you get this wrong, then that's catastrophic. And lastly, speed versus security tensions. So often in the development world, security is seen as this thing that's going to slow you down, and your security team are just out to get you with security reviews and make you wait for security reviews. And shift left is this idea that you should push the security earlier in the process because it's cheaper to fix it there. But that actually overloads developers even more and gives them even more responsibilities. So it's very easy for developers to just move past the security issues in the name of speed. So what now? How do we get past all of these difficulties? So there's a new security paper, new-ish, published earlier this year, with the concept of shift down security. And Before we go on, I'm curious, how many people have heard of shift left first? Majority of people. How many people have heard of shift down? No one. Great. Excellent. So this is a paper published by a few different authors, including Google, Numata, PwC, and IBM. And I'm going to explain just the basic concepts of this. So you have your application team. Your application team is delivering the customer magic. They develop features, they fix issues and bugs. You likely have more than one application team. You may have a platform team. The platform team's job is to offer self-service and automation. So offer resources that the application teams can consume. And then typically there's a security team. And the security team's responsibilities are to manage runtime security, compliance, vulnerabilities, misconfigurations, and the software supply chain. So shift down is pushing some of these responsibilities out of the security team and into the platform. In particular, those related to vulnerabilities, misconfigurations, and software supply chains. So in terms of vulnerabilities, now the platform needs to offer minimal hardened images with as few dependencies as possible to reduce the scope for vulnerabilities, CVEs, and attacks. For misconfigurations, we should be able to manage the policies as code. So that means you can check in a policy into version control, and the policy can be reviewed by multiple people, multiple eyes, and then the actual enforcement of that policy is done through the platform. And then in terms of the software supply chain, the platform team is now responsible for securing and signing off on the images so that we know that what is running in your actual runtime is actually what you said what you expected to be running. And the application team then consumes these hardened images done through the CI/CD pipeline. The policies are managed as code, and there's confidence that the software you're running is what you actually expected. So this is a shift down idea. And here's some of the principles behind shift down. So embrace the chaos. The platform team should own these common concerns around vulnerabilities, misconfigurations, and supply chain. You automate trust as much as possible. So policy as code, policy should be able to be checked into version control and reviewed by multiple people. And less is more. So this doesn't remove shift left, but it can reduce the overhead that you're pushing on your developers and the less sort of education that you need to give your developers in security. And I'm going to leave this barcode here, or QR code, if you want to read a little bit more about how this shift down security works. I'll give people a moment to get a picture. I'm curious, how many people are doing all of these things already in their organizations? A handful, maybe 10, 12 people. How many people are doing some of these already? Maybe a quarter. Okay, so I like this framework, not because I think it introduces something spectacularly new, but because it's something that I think we all understand makes sense to us viscerally. But it's a framework that you can take to people and say, our goal is to shift down the security concerns into the platform team. These are now the responsibilities that the platform should manage versus the security team. So the application developers can focus on writing code, writing creating business value. Security team can focus on setting the policies, managing the exceptions, defining SLAs for the organization. And then the platform team can manage all of the common concerns underneath that. A little bit of final thoughts here. I started about talking about how AI is going to impact authentication, this challenge that I had with my friend about whether we could kill his startup based on vibe coding authentication. No surprises, right? Like, obviously, we didn't kill the startup. In fact, we found lots and lots of security issues, basic things, some of which you can probably spot quite easily, but some of which requires you to understand security guidelines and stay on top of what's new. And then obviously there's no operational support behind any of the vibe coded stuff as well. So there's been lots of conversation here about whether AI is going to kill off architecture or architects as a job role. And I don't think it's going to kill off architecture, but I do think that architecture is a technical and a social activity. And the social side of it is going to rise in importance because we need to give people frameworks that they can understand and think about and communicate to non-technical audiences too. And that social side of communicating and understanding and coming to a consensus around a technical vision is going to be more and more and more important in our work and as the expectations of our work increase as well. And someone reminded me of this the other day, that when I was an engineer at Google, and there was a term that they used to say about how you should feel when you're working on something. And the term was uncomfortably excited, right? Like this idea that there's something that's so exciting, but it causes you stress and anxiety because you're not sure how it's going to work out or why or in what way. And I have been a skeptic about this in the past, but I would say now I'm probably uncomfortably excited about the changes that are coming up. And I'd like to ask, how many people feel uncomfortably excited by this? Yeah, probably like a quarter of the room, right? So these changes are coming. We need to face them and we need to understand them, and we need to master this feeling of anxiety that we have about AI and how it's going to change our work. And that's it for me. Thank you very much. These slides are on my blog at oishell.com. Thank you.